Ladies and gentlemen, welcome and thank you for joining the Monitoring Datasets Discoverability Matrix Workshop. Before we begin, please ensure you have opened the chat panel by using the associated icon located at the bottom of your screen. If you require technical assistance, please send a chat to the event producer. Please note that all connections are muted until the Q&A portion of the call. We will give you instructions on how to ask a question at that time. You may submit a written question at any time by selecting all panelists from the drop-down menu in the chat panel, enter your question in the message box, and send. As a reminder, this conference is being recorded. With that, I will turn the call over to Andrea Copping. Andrea, please go ahead.
Thank you very much, Luke. A good evening or good morning, everyone. Thank you very much for hanging in with us while we got these technical issues resolved. So sorry to be starting late, but we're very pleased to have you joining us for this Monitoring Datasets Discoverability Matrix workshop. Michaela Freeman will be delivering the majority of the workshop. I just wanted to give you a little bit of an overview of why we're here and who we are. If you go to the next slide, please, Michaela. So today, I'm just going to do a brief introduction on OES-Environmental. We will be doing an overview of the data transferability process, and then the vast majority of the time will be spent on this monitoring datasets matrix. Michaela will do a live demonstration, worked really well on it earlier today, we'll see again, with some examples of how one would go in and find the particular data sets one was after. And there'll be questions and feedback, and I do want to encourage you at any time to ask questions in the chat box, and we'll monitor those so it doesn't get all the way to the end and you've sort of missed your train of thought. I also want to note for you that we are recording this session, not that we will necessarily put up the questions and answers, the audio of them, but really for our own needs to be able to sort of take notes and keep track. Okay. With that, if you go to the next slide, please, Michaela. We are here today representing OES-Environmental. The Oceans Energy Systems Collaborative is a group of 26 nations engaged in developing ocean energy. 15 of those nations are participating in this task, OES-Environmental. You see them listed there. And the purpose of this task is to understand the environmental effects of marine renewable energy, particularly as this allows us to advance towards consenting or permitting and getting devices in the water. So much of what has hung us up really over the last 10 years is not having sufficient information and data from devices that are in the water interacting with the environment. We have just recently, OES-Environmental has released the second State of the Science report, the 2020 State of the Science in June, and that is open for public comment now. If you went to TPIS, where you signed on to this webinar, you'd find the link there. One of the themes in that report is this idea of risk retirement and data transferability. How do we use information that has already been gleaned from other projects, research studies, et cetera, and make it applicable? And today's webinar really focuses in on the practical aspects of finding those data and what you can do with them. So with that, I'd like to turn it over to Michaela for the content here.
All right, thank you, Andrea. So today I wanted to start with a few definitions, since you'll hear me talk a bit about stressors and receptors. I assume that most of you are familiar with them, but just to make sure we're all on the same page as we talk about these. So stressors are the parts of a device or a result of the device's function that may cause harm or stress to a marine animal, habitat, or ecosystem process. Through collaboration with the marine renewable energy industry and writing our 2016 and 2020 State of the Science reports, as Andrea mentioned, it became apparent that there are key stressors, and those have become the focus of our work. Today, we'll focus on the 6 you see on the screen: collision risk, underwater noise, electromagnetic fields, or EMF, habitat changes, changes in flow, and displacement. Receptors, on the other hand, are the marine animals, habitats, and ecosystem processes that may be affected by the stressors themselves. So some of you who may have joined us for a previous webinar or workshop may have heard what I'm going to say here, but I think it's really important to start here and explain why we're doing the work that we do. So we know that there's a perception among the MRE industry that it takes a lot of time to get projects in the water, that consenting is long and complicated, and that there are extensive baseline data and post-installation monitoring requirements. Our perception is that the regulatory community faces a lot of challenges too. There are not many devices in the water at this point. There are new technologies that we don't know much about, and there's lots of uncertainty remaining about potential environmental effects. All at the same time, regulators are mandated to protect the marine environment, to follow a suite of different regulations and laws, and make decisions on applications for marine energy projects. We believe that by getting devices in the water, we'll be able to learn more, and we can mitigate some of these challenges faced by both the industry and the regulators, and that this needs to be done in an environmentally responsible manner. And as Andrea mentioned, this is where we're working. We're working in this space to help bridge these gaps and move the industry forward responsibly. So by engaging with the U.S. regulatory community through online webinars and a regulator survey, as well as talking to the larger international community, it became apparent that there was a need for sharing data between marine renewable energy projects in order to advance the industry. We think that data and information collected through research studies and monitoring from other projects should be able to inform new projects. We do recognize that some site-specific data will be needed for all new projects, but that existing data should be used as much as possible. We've deemed this data transferability, where data from already consented marine renewable energy projects or analogous industries should be used to inform consenting for future projects. It's important to note that data that might be transferred should be collected consistently to allow for comparison across studies. And to define data, this could include raw or quality control data, but more likely it comes in the form of analyzed or synthesized data, information, or reports. So this picture on the left of the screen is our data transferability process. In 2018, we developed this process in order to guide transfer and to systematically evaluate data sets from other projects or research studies and bring them into consenting processes that are moving forward now. The processes you see include the framework as the focal point, as well as a data collection consistency table, best management practices, and the monitoring dataset discoverability matrix. The framework classifies the stressor-receptor relations, which uses 6 stressors I mentioned earlier, and this is also what the matrix is built upon, as you'll see later. The data collection consistencies table outlines parameters for comparison of data between projects, and our colleagues at Pacific Northwest National Lab lead the Triton initiative, and as part of that project called PFIT, they are working on assessing environmental monitoring methods and technologies, and they started conducting field trials. So they're working in this data collection consistency space to see how we move forward. The best management practices suggest 4 practices for implementation of data transfer, and then the matrix catalogs relevant data sets, which I'll explain in more detail further in the presentation. All of these components work together to achieve data transfer, and we vetted this whole process that's been really iterative with regulators and the marine renewable energy community. We've incorporated feedback that we've heard during online workshops such as these and workshops at international conferences. And really we wanted to make it all iterative so that what we are developing this process is useful to those who would put it into practice. So as Andrea mentioned, we've also been working on the concept of risk retirement. Risk retirement has been used in the industry, but there have been no real definitions. The idea here is that as with data transfer, we want to decrease the data collection burden on developers and also decrease uncertainty, all by assessing for certain interactions if potential risk could be retired or not fully investigated for every project. And here we're specifically talking about small development, so 1 to 2 devices. We really want to rely on what is already known and the availability of similar or suitable data, again, from those consented projects, analogous industries, or research studies. And of course, this doesn't change or replace any regulatory process, but it's really focused on making the information more readily available and usable. It is important to note that through this process, a risk that is retired can be reexamined in the future as more information becomes available, And we specifically think there might be a need for this as the industry moves towards larger arrays that may be likely to re-examine effects that are different between 1 to 2 devices and a handful or larger arrays going in the water. We have looked at interactions so far that we believe to cause little risk and describe how that information can be applied to new projects. So through a series of workshops and expert consultations, we've considered underwater noise and EMS likely ready for risk retirement for these small numbers of devices. So what this means is that if a developer were to put forth a proposal in an appropriate location for 1 to 2 devices, perhaps there does not need to be a great deal of monitoring for these 2 stressors. There are certain caveats, such as the need to know what the sound output from new types of devices are, or the need to know what the power level carried through certain configurations of cables will be. But these are really an attempt to move towards doing things in a more standard manner so that each study doesn't need to be redone at every new site and for every new marine energy deployment. So at the bottom, this is our risk retirement pathway that we've developed in order to assess the ability to retire risk for specific projects. And this leverages what is already known and discoverable through the data transferability matrix. And that is where this box comes in. So we realized through developing the data transferability process that data transfer is really a key component in the ability to retire risk. And as we learned from previous projects, we're able to use that information for future projects. And so I won't go into a ton of detail on the pathway here. We're actually planning to hold a public webinar in September on the risk retirement process. And there are also some previously recorded webinars that are available on TSIS. But in step 2 here, where you examine existing data, this is really where the data transferability comes in and the use of the monitoring datasets discoverability matrix. So with that, I want to pause for a second before we move on to the matrix and just see if there are any questions, anything I can answer at this point, since I know that was a lot of information all at once. So again, if you have a question, please feel free to put it in the chat box, or you can raise your hand and ask a question. And while I give everyone a moment to type in their messages or enter the queue, I do want to note that we have pages on TSIS for both data transferability and risk retirement. I have the links to both those pages at the end of this presentation. And there's a ton of detail on each of the process, the different parts of the processes. And then at the bottom, we have recordings from previous workshops and webinars that we've run. So if you're interested in more detail about either of these, that is available on TSIS. And we do have reports as well that explain both processes. So I don't see any questions, so I'm going to move on to the matrix. But please do feel free to enter in a question at any time in the chat box. We have both Debbie and Andrea here who will keep an eye on those questions and make sure they get answered either while I'm talking or after. Okay, so with that background on why we developed the data transferability process and the different aspects of it, I'm going to focus the rest of the time today on the matrix. The matrix was developed after talking mostly with regulators about the ability to transfer data to aid consenting and continuing to hear that there was a need to easily find and access data that can be transferred. We started to workshop that idea around with the larger marine renewable energy community and felt that this was something that we could develop and host on our TSIS platform. So the matrix makes data sets from existing projects accessible so that regulators and the larger MRE community can transfer data for consenting future projects. And again, this is categorized by the 6 stressors that we've been talking about here today. So the matrix uses similar classifications as the framework, though it does get into some additional details. Some of these categories include stressor, receptor, site condition, technology type, and project size. And each of the characteristics that fall within these categories is specific to a stressor. So for instance, for site conditions, those relevant for underwater noise are, is it a quiet or is it a loud environment, which are different from those that are relevant for benthic habitat changes, which we're looking at, is it a soft bottom or a hard bottom site? And you'll see that as we go through the matrix today. The data sets in the matrix come from OES-Environmental metadata, and I'll get more into detail of what metadata is on the next slide. And it is an interactive tool that allows users to sort through the defined categories and characteristics and choose those relevant to filter the metadata and provide results and data that are relevant for either regulators that are trying to consent a project or developers aiming to submit an application. And we hope it's relevant and useful for the entire marine energy community. It could be researchers who are looking to find some data gaps or anyone who is just interested in environmental effects of marine energy devices. So I'm going to take a second to go through metadata because, as I mentioned, the results are from OES-Environmental metadata, so this will help in our understanding once we get to the results page of the matrix. You'll see at the top here there's a link for our TPIS page for OES-Environmental metadata. This presentation will be available on TPIS later, so you'll have access to all of the links we're providing today. Metadata has been collected for marine renewable energy project sites and research studies since 2012. We split them into project site forms, which are for devices or test sites, and these are for projects that are planned or currently or previously deployed. And then research study forms are for current or ongoing research. And the information provided on TPIS for each of these differs a little bit, which again you'll see as we walk through the matrix and the results. So OES-Environmental has designed metadata forms or questionnaires that solicit information from developers and researchers involved in environmental monitoring and studies. And the information collected and shown captures many activities around the world that are exploring the potential environmental effects of these devices. And it provides detailed information such as links to associated reports, details on licensing and project or research progress. For projects, it shows information about baseline and post-installation monitoring, and for research, it shows key findings. And this picture you see on the right is an example of a form for Stability 10 tidal turbine, and I'll switch over to the online version of this to show you it in a second. So the information on metadata is mostly received directly through project developers or researchers who fill out our metadata forms, and then we publish that information on TPIS. We are continually adding new and planned projects, and we do our best to reach out to relevant people to make sure that any projects and research studies are captured on TPIS. And we do request updates for ongoing work on an annual basis to make sure the information is reliable and accurate. We do have blank metadata forms up on TPIS, and we are always looking for new projects and research studies. So as you're going through the matrix, or if you're checking out the metadata page and you don't see a project that you're working on or a research study, please do fill out a form and email us. We would love to have additional information. So I am going to switch over to the metadata form and just walk through this briefly. So this is the Sabella tidal turbine form. At the right of all metadata forms, you'll see a project site and a details box. These are just a quick snapshot of some information. So the project site has who the project manager is, it has a start date and end date if we have that, and when the information online was last updated. And then we also have a contact. The details here is actually mostly comes from the matrix information. So we did a big update of our metadata forms and what questions we asked so that we could get additional detail that would be relevant for the matrix and would allow us to sort through the different characteristics. On the left side here, you'll see a description of the project. There will be something about the location, and also at the bottom you'll see a map where it's geotagged, and this filters into our map viewer, which is a way to search those documents, reports, metadata forms that are geotagged, so you can look at them based on location. And then there's project progress and relevant papers, reports, and research studies. If you scroll all the way to the bottom, this is where we get into the post-installation or baseline monitoring data. This form, they provided us information with post-installation monitoring. Other forms, you'll see both baseline and post-installation or vice versa. All right, with that, I am going to go back to our presentation, but I just wanted to give you guys a quick view of metadata so that when we look through the results, it'll make a little bit more sense of what you're looking at. So I'm going to walk through the matrix now. I wanted to first provide you the link. I do want to first mention that we had to do some last-minute updates to the matrix. So while it is not yet available online through this link, it will be within the next few days, and I will send out an email to all those who attended today to make sure you know when it is available. But when it does come online, you can find it at this link here. So first, I just want to show what the matrix looks like when you go into it. So the matrix is this gray block with the different tabs of stressors at the top. I do want to go into this web page, which is actually the matrix web page. You can't actually access this through the link I provided. However, right here you can see that the block is missing, so that's where you'll find the gray box when you look at it later in the week when it's up. But I did want to point out we have a little blurb about the matrix up here, but most importantly here at the bottom, which will be under the gray box, we have instructions on how to use the matrix, and then we've included a PDF which walks through with pictures how to use the matrix step by step. So after this, if you're looking through the matrix later in the week or in a month or whatnot, you can come back to these instructions here to help walk through the matrix. I do also want to point out where to find TPIS from the main menu. So this is our TPIS homepage. And if you go to the Tools drop-down menu, you can see the last option is the MRE Discoverability matrix. And you can also access the matrix that way. And I want to point out as well that you can also access OES-Environmental metadata from this Tools drop-down menu as well. I am going to walk through an example with the matrix to kind of show how it's done, and then I'll open it up for questions. So you can see at the top here, we have tabs for each of the 6 stressors. I do want to point out that for habitat change, we have a tab for benthic and for water column. As we got into the stressor, we realized that the characteristics were quite different between the two, and so we split them out. So there are 7 tabs at the top. So I'm going to go through an example with underwater noise. So when you open up each new tab, you'll first see the stressor and the receptor listed. And the category that you're looking at will be up in bold. So you can see that right here with the different characteristics here. So as you click through the matrix and filter different options, you want to click on the blue dot, which will open up the next category in the matrix, and you can keep clicking through, and you see that we have new categories that open up, and once you get to the end, that will be shown with these white dots, so you know that you're at the last set within the matrix here. You can at any time close a different tab by clicking on the blue button and closing it, or opening a new tab, new set of characteristics earlier on in the matrix. So I'm going to show you an example that's looking at a tidal turbine, of course, with underwater noise, and we're interested in marine mammals in a noisy environment. So what I'm actually going to do is I'm going to click the text on tidal, and you'll see that when I do that, not only does the blue dot get highlighted, but also the dots here become translucent. And so that's just showing that as you click this title option, all of these will be included in your results. If that's not what you want to choose, you can click back on the text here, which will then bring the white color here, and you can then choose one or a few different options to filter through. But for my example, I'm going to choose title and all of the project scales. And as you'll notice, also this View Results button here, you can't click it until you have something selected. As soon as I select title, you'll see that it highlights in blue, and then you know you're ready to view your results. So we'll click View Results, and this will open up a new tab. This allows you to go back into the matrix and choose different options, compare results. So you'll have a new tab that opens. Up at the top, you'll see right here, these are this shows the options that you filtered to get your results, so that if you have a few tabs open, you know which one you're looking at. Below that is a search bar where you can search for key terms. And then below that is the results. And so these are split into 3 types of information. We have the baseline and post-installation monitoring, which, as I pointed out, are from project site metadata forms. Below that, if you keep scrolling down, are research studies, and these are from the research study metadata forms. I do want to note that these are filtered only by stressor and receptor. Due to the nature of the forms, they don't have the granularity that the project site forms do. So while these might be a little bit more general in the results that you get, they will always be relevant to the stressor and the receptor that you've chosen. If you continue scrolling down, our last category of results here are key documents. And these are documents that have been reviewed and that are really key in our understanding of the impact of the stressor. Many of these documents come from the evidence bases that we've gathered to assess risk retirement for the different stressors. And right now, because we've assessed underwater noise, EMS, and we will soon be looking at habitat change, those are the stressors right now that will have key documents showing up as results in the matrix. But we'll continue to add documents, and we are working on compiling key documents for changes in flow, and then we'll focus on adding collision and displacement. So as you check back in a few months later in the year, we should have those different ones available and up on the matrix. But as I mentioned, all of these documents are reviewed so that we can make sure we have key documents here. I do want to note at any time you can go into the TETHIS knowledge base and you can look at any documents. You can filter by stressor, receptor, other categories there. And so it's always available to find more underwater noise documents through the knowledge base, but we wanted to provide some key ones based on your results. So I am going to scroll up and show you an example of what you get when you click on one of these results. I do want to mention for the baseline and post-installation monitoring, for all of them you'll have a title, a description, and a country. And the way that we have named these is by the project name, and then whether it's post-installation or baseline information. And then you'll see the receptor following that. I do want to note that the numbers following it are merely to just say that there are 3 different studies, as you'll see here, that are baseline data on marine mammals at this one specific project site. So I am going to open up the Scheinfeld Lock CGen post-installation data. And when I click on that, we actually go directly to the project site form for metadata. So this is why I wanted to show you the metadata in the beginning. This is the bottom table of post-installation monitoring. Now this opens up a new tab where the matrix actually highlights that result you're looking at. So you know exactly where you're looking and what result you searched for and filtered for in the matrix. So you'll see here we have our stressor receptor, there's a study description, design and methods, results, and then the status. And under results here, we can see that after 3 years of post-installation monitoring, no major impacts on marine mammals have been detected. And they do specifically state that findings are described in more detail in the environmental monitoring program. So by scrolling up on the metadata form, past the 2 tables at the bottom, we can go to the papers, reports, and research studies section, and we see that the environmental monitoring program final report is available. So again, we can click on that, open it up, and it'll take you directly to that final report where you can find the document here. For some of them, we do have the actual attachments. For others, we have a link to where you can find it online, and sometimes we provide both. And you will also find an abstract and some more information about the publication. So you can go into the reports that are provided to find more details. If you want more detail beyond that, you can also scroll up to the very top of the metadata form. And as I mentioned, there is a contact listed for all of the metadata forms. And so here you can see the contact is listed as Joseph Kidd. In this box, I am actually logged out of TPIS, and I wanted to show you this because for the contact information, you will need to have a TPIS user account and be logged in to access that email address. So when you go in and use the matrix, do make sure that you're logged into TPIS so you can contact whoever you would like to for additional data. I do want to note that we are not hosting data through the matrix, but instead we're making it accessible, as you can see, by filtering the different characteristics that you want and then providing it in the monitoring, post-installation monitoring baseline tables, and then further through reports and through contacts. So you should have many different avenues to find the data that you're looking for. So I want to take a second and pause for any questions that I can answer. If you guys want me to go through anything else, I can do another example as well, but I'll take a second and field any questions.
Michaela, there was a question in the chat box, which I kind of answered, I think, asking about the entanglement or entrapment stressor, and how do we categorize this? Is it like collision? And for those of you not familiar with it, it's been raised in recent few years that having floating arrays of wave devices or floating offshore wind platforms with mooring lines going down to the bottom, could this provide an entrapment or entanglement risk to large marine animals, largely marine, whales, although it could be others. And we have looked at this some. There are, in fact, no data sets available, so there's nothing in the matrix. We do think this is a pretty low risk. It does resemble the idea of collision to some extent, but clearly it's much less dangerous for an animal than a rotating turbine blade. So there's nothing in the matrix now, but there could be in future if there were, in fact, data sets produced.
Mm-hmm. Yeah, that's a good point. And I should point out that we do address entanglement in the 2020 State of the Science, so there's information there. But yes, as Andrea mentioned, it is not currently in the matrix. As you will probably notice as you go through the matrix, there are some stressors that have more information and data available, and other stressors that have fewer studies. And so, as you might imagine, with not too many deployments in the water so far, the data is sometimes limited, especially for stressors such as displacement, where we don't yet have array scales to look at the impacts here. So as we get more deployments, as we get additional metadata forms and more information, the matrix will continue to be more and more of a robust tool. With that, we've also chosen to use kind of more simplified categories. As you can imagine, opening up each individual stressor and all the different options, you actually have tons and tons of different options. And so to keep the selections to a manageable amount and make it useful, we've chosen some more general categories. Again, as we get more data and information, we'll look at if there's a need to update the matrix and get into some more of that granularity. I see someone said you've had trouble accessing the matrix webpage in the past few days. The block doesn't show. So I'm sure I answered your question already, but just in case, unfortunately, we've had to do some last-minute updates. So this gray block here is what you'll see in the middle of the page here. Let me see if I can find it. Yeah, so right here is where you'll see the page. I'm actually showing this to you on a development site. We kind of had to do some quick fixes so that I could run this demonstration and show you how to use it. So it will be available hopefully by the end of the week, if not sooner. So if we want to take a few minutes, it would be great to hear any thoughts on data transferability. We would also like to know, after viewing the matrix, can you make use of it for transferring data to consent an MRE project or to fill out an application for a project? And then, of course, we welcome any general feedback on the matrix. As I mentioned before, any of these tools that we're developing or processes, we want to make sure that they are useful and are benefiting those who will be accessing them. I will just run through a quick example. First, I wanted to open up the EMS tab and just show you, I already have this one all the way open, but as you can see, if you go back between underwater noise and EMF, you can see that the categories we have are quite different. So we spent a lot of time coming up with the categories that we thought were relevant for each of the stressors, and we worked with those in the industry to also make sure that these made sense and these were relevant for everyone's use. So you'll see that those change between the different stressors. The example I'm going to show is actually in collision. So I want to look at collision with fish. I'm going to open this up so you can see how this differs from the other ones that I'm showing. Again, you'll see there are different categories. So in collision, we're looking at water depth, channel width, technology subtype. Is it a bottom-mounted tidal turbine? Is it floating on the subsurface or floating on the surface? And then again, what's the project scale? So for this, I want to just show some results of collision with fish. As you guys might have seen in my invitation, I did ask for people's interest, and I heard lots of interest in collision and some interest in collision specifically for fish. So I wanted to make sure that I showed an example relevant to attendees' interest. So again, we'll walk through the matrix, opening up the blue dots to click on a new section, and then clicking the text when you're ready to view the results. So opening the results, you have the selections you made up at the top. And I'm actually going to go down to a research study to show you what those look like and how they differ from the project site. So we're going to click open this adaptable monitoring package, similar to the baseline and post-inflation monitoring. With research studies, you have title, description, and country. I'm going to open that up. And again, you will see we kind of have this box here that gives you some quick information on the research. It has the researchers, the status of the project, the start date and end date if applicable, the stressors and receptors that this research is relevant for. So you'll see here it's relevant for collision and fish, but also several others because this is monitoring technology that they use to look at a few different ones. When the information was last updated, and again, a contact. I do want to point out for research studies, oftentimes under this principal investigator contact information, there may be other people listed in the study, so there are additional emails that you can reach out to if you have questions, if you're looking for more data. Below that, you'll see a description. This one has a video archive showing some animals swimming around that are captured with the adaptable monitoring package. And you'll see the location of research again, some project aims, the study progress, key findings, and some related publications. So you can look at all of these for more details and information. So with that, I think that runs through most of the demonstration that I wanted to show. Again, if there are any questions, please don't hesitate to ask. And I know that you guys can't use the matrix right now. If any questions or feedback comes up while you're looking through the matrix, don't hesitate to reach out. I do see a question. Let me read through it real quick. So it's been these early experience that government regulators in Australia are reluctant or not willing to accept research data from outside the country. What key attributes of the matrix can be used to provide confidence of the relevance of data/research to Australia? That is a great question and something we have definitely heard from other folks in different countries. I know I heard that from people I was talking to that were permitting the Pathways site in the U.S. and Oregon. I think this ties really nicely into the data transferability work that we've done. So as I mentioned, we have the framework that puts together how you transfer data and the best management practices. So I think by combining those different processes and aspects of the data transferability process, you can use this information from the matrix and help guide how you do the transfer, why it's relevant to transfer data from one location to another, and hopefully be able to kind of explain a little bit more how we can do that. Andrea, I don't know if you want to add anything to that.
No, I think you have it exactly right. And I think we are very sensitive to the fact that there is a lot of concern from countries, especially that are just getting started in this marine renewables, that there really isn't great applicability from other places. We all know that Scotland's kind of cornered the market on doing all this, but does that matter in my country? And one of the things we'd like to do as we progress along this path is put together some online meetings with regulators from several countries, because we think a regulator from one country has a lot better insight to explain to a regulator from another country why they find these kinds of data sets useful. So that's just sort of one extra avenue we're going to be working towards. So if you think about the regulators you would like to have involved in the discussion of that sort, that would be really helpful. I think this is the sort of thing that if we get a few regulators in a few countries using other data sets, it'll start to snowball. But that initial idea is a little bit tough.
Yeah, and to add on to that, one thing we've heard is that there's actually a bit of data transfer that has been going on in the marine energy industry and even in other industries, but it's actually not well documented. So people have this kind of institutional knowledge that they hold on about when it's happened. And one thing that I'm interested in looking at is, can we document those times where data transfer has happened? Why was it accepted by regulators, and what can we learn from that? Because we think as it becomes, as Andrea said, kind of more of a normal scenario, that it'll be more and more accepted by regulators to be transferring data. And we have heard in cases where there's no research and no understanding that regulators have been open to transferring data from other analogous industries to be able to inform their decisions. And that seems to kind of be a point when, there's really not much to go off of, and so any information helps. So we hope to kind of gather all that information and put it out there so that we can move data transfer forward.
Kelly, you have another question asking about definitions for matrix terms such as narrow and wide channel. And I think there's another one that's sort of loud and quiet. So you might just mention what is, how we came to those.
Absolutely. And we will be adding this onto the matrix so that it is easily usable there. As I mentioned, the matrix is based off of things within the framework, and the framework does define these tools. We have a document we developed earlier that has a lot of that information. But for collision, which is where the shallow, narrow, the shallow and deep, or narrow and wide channels are, we have defined shallow channels as having a depth less than 40 meters, and deep channels at those having a depth greater than 40 meters. Narrow channels, we've said those are width of less than 2 kilometers, and wide channels are those greater than 2 kilometers. For underwater noise, we have the isolated and quiet environments, and those are noise measuring less than 80 decibels. For noisy environments, those are environments with noise measuring greater than 80 decibels. And I do want to point out that we did a big update of our metadata form so that this sort of information and details were available, since this actually wasn't previously provided. And we found that in most deployments, the information and data isn't available for what the background noise levels are. So for a lot of these, until we have that granularity, we've actually chosen both categories. So when you're searching through underwater noise, you might get a deployment that's listed as both isolated, quiet, and noisy environments, because that data is not available yet. So we wanted to make sure we were providing more information that would be applicable rather than defining it too narrowly and condensing it down. Hope that's helpful. And of course, when we did this, we kind of had to choose ways to split it off. So if you have any feedback on that, we welcome that as well. All right. Are there any additional questions?
Yeah, I don't see any other questions. We have another affirmation that it's a good idea to have a multi-country regulator information exchange. We're going to try to work towards that probably a little later in the summer.
All right. With that, I'm going to return to our PowerPoint and walk through a few next steps. Please don't hesitate to ask any questions that come to mind as we're going through. I can answer those after the last slide. So please feel free to keep entering those in the chat box. So the recording of this workshop will be available up on TPIS shortly, as will the full matrix itself, and I will send out an email to everyone who attended today to make sure you know that the matrix is up and running on TPIS. As I mentioned, for more information on the data transferability and risk retirement processes, you can find these pages on TPIS at the links below. And again, this presentation will also be on TPIS, and so the links will be accessible for you there. So next steps for OES-Environmental is really to focus on continuing our risk retirement efforts. As I mentioned previously, we are planning to hold a public webinar in September to provide updates on the risk retirement process. In 2019, we focused on the ability to retire underwater noise and electromagnetic fields and received a positive response. And so during 2020, we've been focusing on gathering the evidence base for habitat change and changes in flow, and we're working towards assessing the ability to retire those risks. In August, we are going to hold an expert forum on habitat change to bring together experts working in the habitat change field to assess if we can think of that risk as retired for small numbers of devices. So if you are interested in attending, please do email me. My email is on the next page. We're also working on developing guidance documents for each stressor that will allow the application of risk retirement when consenting projects. So we aim to have one document that is general enough to apply internationally. And then working with our OES-Environmental country analysts, we want to also have associated country-specific documents. And the goal here is that these can be used by regulators to aid understanding and gauge the ability to retire risk for projects with small numbers of devices. And we want to make this useful in the regulatory context. So while we'll talk about stressors and receptors, we'll also try to make those country-specific documents relevant to the laws and regulations that each country is working with. So that is all I have for you today. I wanted to thank you for joining us today. There is mine and Andrea's email addresses there, so please don't hesitate to contact us with any questions or feedback. I'm happy to run through additional demonstrations of the matrix or field any more questions, so please let us know if you have any.